We want to solve 2ix squared plus root 8x minus root 3 equals 0, either by using the quadratic formula or by completing the square. I'm going to use the quadratic formula. X is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Looking at my equation over here, I have that a is equal to 2i, b is equal to root 8, and c is equal to negative root 3. So x is going to be negative root 8 plus or minus the square root of root 8 squared, take away 4, times 2i times negative root 3, all divided by twice 2i. So that's negative root 8 plus or minus the square root of 8 plus 8 root 3 I, all divided by 4i. So we need to think about 8 plus 8 root 3i. So that's a complex number in the first quadrant. This is 8 root 3. That means that this would be pi by 3 radians. And 8 squared is 64. And this one will be 64 times 3. So that makes this one 256, or the square root of 256, which of course is 16. So 8 plus 8 root 3i is 16 cis pi by 3. So if we think of that as being z squared, and we can write it as 16 cis pi by 3 plus 2n pi, then z is going to be 4 cis pi by 6 plus n pi. That means that one of the solutions will be 4 cis pi by 6, and the other one will be 4 cis, take n equal to negative 1, and it will be negative 5 pi by 6. So this will be 4 cos pi by 6, which is root 3 on 2, plus I 4 sine pi by 6, which is a half. And the other one will be negative 4 root 3 on 2 plus I times 4 times a half. And so that's going to be 2 root 3 plus 2i and negative 2 root 3 take 2i. This one's actually negative a half because we're in quadrant 3. So those are my plus and minus square roots up here. And so we can say that we have negative root 8 plus or minus 2 root 3 plus 2i, all divided by 4i. So we have, using the plus, negative root 8 plus 2 root 3 as a real part on top, plus 2i, all divided by 4i. And the other one is going to be negative root 8, take away 2 root 3, take away 2i, all over 4i. Now we don't want the I in the denominator here and here. So we could multiply top and bottom by I, and then we would have, so this one gets multiplied by I, it will be 2i squared, which is negative 2. And then we would have plus I into negative root 8 plus 2 root 3. And of course that would be over negative 4 because we multiplied the bottom. And the other one is going to be, so I squared here is going to make that into a positive 2. And then we're going to have I into negative root 8 take away 2 root 3 all over negative 4. Now obviously we shouldn't have the negative 4 on the bottom, so if we multiply top and bottom by negative 1 now, we're going to get 2 take away I negative root 8 plus 2 root 3 over 4, and then we're going to have negative 2 take away I into negative root 8 minus 2 root 3 all over 4. What do we notice about the roots? We could probably play around with them a bit more, but there's no need. The important thing, look at the imaginary part. One is not the negative of the other, so they are not conjugates. And once again, we had a coefficient that was not real.